helpful hint for that last problem is one of the two integers, n and n plus 1, must be even. So we already know that the product n times n plus 1 times 2n plus 1 has to be a multiple of 2. You can't have two consecutive integers where both of them are odd, for example. That wouldn't work, right? The way numbers work is alternating even, odd. 1, 2, 3, 4, 5. Odd, even, etc. Okay, so we know that if we multiply n by n plus 1 by whatever else, that whole thing is going to be a multiple of 2 because I have at least one even factor. Hence, it remains to show that it is also a multiple of 3, and then they're giving you 3 cases to work with. Okay. So last things we need to talk about in this section are some fallacies to watch out for. These are some pitfalls, some logical errors that people tend to make. And the first one we're going to talk about is the fallacy of the inverse, or the denial of the antecedent. And if you recall, the inverse of if P then Q, if this is the if the original statement is if P then Q, the inverse was the one where you just negate the P and the Q and keep everything where it is. And again, as we said before, this is not logically equivalent to if P then Q. Okay, very important to keep that in mind. So if I try to use this as a logical structure, it's in a way trying to prove that the inverse is true, but we don't know that the inverse is true even if we assume that the original if P then Q is true. If you are struggling with that, you should check that if P then Q and not P then not Q, check that this is not a tautology. And you can use a truth table for that. You can use a a sequence of logical equivalences from the table that you had on your test. So that's something that people watch out for, or something that people need to watch out for. Okay, so here's an example. If I say dictionaries are valuable, remember we can think of that as if X is a dictionary, then X is valuable. And then if we assume that a book is not a dictionary, this book is not a dictionary, we can conclude that the book is not valuable. Okay, maybe in everyday speech people talk like this and they make this kind of assumption and they operate in this way, but that doesn't work in math. It doesn't work in logic. So I want you to think more about why this is not a valid argument, and we will now consider one more fallacy, which is the fallacy of the converse, or the affirmation of the consequence. Okay, this form is if P, assume that if P then Q is true, assume that Q is true, which already seems very fishy already, and then you can conclude that P is true. And again, this is using a faulty logical structure. Okay, so if I have if P then Q and Q, then P, you can check again, this is not a tautology. which means this structure of an argument is not going to be valid. Okay, what this structure does do is it proves the converse, and as we said earlier, if I have the original statement, the converse is not necessarily going to be true, right? And remember that the converse was when we take the if P then Q and write it as if Q then P. Again, this is not logically equivalent. It's possible for them both to be true in a given situation, but they're not guaranteed to have the same truth value because they're not logically equivalent. Okay, so one last example for you to think about is the argument, no medicine tastes good, this drink tastes bad, therefore this must be medicine. Is that a valid argument, and why? So to help you out a little bit, I'm going to write this in if-then language in a way similar to how we did in a previous example. All right, so no medicine tastes good. Okay, so I could write that as something like, for all x, if x is medicine, then, I should say, if x is not medicine, then x tastes good. And then the second statement would be, this one here, would be, well, x tastes bad. Okay. I think I made a mistake. I'm not very good with editing right now. I'm going to have, we're going to have some messy videos right now. So let me start that over. Just, we're just trying to keep things going here as best we can. I made a mistake. If it happens in class, I would do the same. I would erase and I'd start over. So I think a better way to translate no medicine tastes good is to say for all x, if x is a medicine, then x tastes bad. Tastes bad is the same as saying doesn't taste good. Okay. Now, to translate the statement, this string tastes bad, I could just translate that as x tastes bad. So notice what we have now is we have x is a medicine is P, x tastes bad is Q, x tastes bad is Q. The conclusion is that x is medicine. So notice how they're using the fallacy of the converse argument structure, which again is not valid. All right, so just to kind of sum things up. Oops, the writing got attached to this piece. Sorry about that. So proving an implication, if P then Q, you start by assuming P is true. We're going to do that a lot throughout this semester. Using the information from assuming P is true, work with definitions and other known results to show that Q must also be true. Sometimes P is something that you can break into multiple cases, and you prove each implication separately, as above. And then make sure to not only write the mathematical expressions clearly and use different variables if the quantities involved may not be the same. You should also use words appropriately, follow the models you're seeing. And on the next slide, we'll look at a little bit of what I'm talking about.